Okay, on today's welding tutorial, we're doing aluminum. This is 6061 T6, and this is cut on a water jet. And we're going to break these apart like we would our model pieces that you get in the toy section at Walmart. And we'll start cleaning them up and getting ready to weld them. Okay, I'm going to be welding these. When I get them all cleaned up, I'll be putting them in that fixture. And I'm going to be welding these with a 3/32. I'm thinking a 3/32, maybe a 1/8, 5356 TIG aluminum welding rod. The reason being it's most compatible with 6061 T6. And that if you use a 4043, it will still work. The structural integrity is going to be a little less, of course, but with a 5356, the melting point is somewhat higher. So that will give it a cool down a little bit quicker. So the purge will be a little bit cleaner. And because oxygen is not oxidating to the melting metal so much as when the argon leaves the weld puddle, it'll have cooled down quicker. So it'll actually leave a cleaner, a shinier weld. Oh yeah, I work in an illegal chop shop somewhere in Mexico. So if you hear some beating and banging in the background, mind your business. Now, for my more serious, no-nonsense audience members out there, that last part was a joke. Okay, I went ahead and polished the areas that are going to be welded. Probably didn't have to do that, but hey, I'm a little OCD, so that's kind of what you get with a TIG welder most of the time. But turn the machine on, turn the gas on, and switch my machine over to AC. Get ready to weld. Okay, I'll be using these spring clamps to hold everything in our fixture. I've lined everything up with the holes in our fixture, and I'm going to tack here and here first. Okay, for this purpose, I'm going to be using a 3/32 gas lens with the collet, of course, a number 8 cup, and this will be 2% thoriated tungsten, 3/32, of course. I know it sounds a little redundant in the way I'm repeating all this, but believe me, some people that are starting out with this need to be told everything. So the 2% thoriated is an all-around. You can do steel, you can do aluminum with it. A lot of people say, oh, use the green, use the pure tungsten for aluminum. You don't have to. This does just fine. I've been doing this over 30 years and never had a problem with it. And I'm going to tell you one thing more. People will say, reverse your polarity so you can ball the end of the tungsten up. Well, look, after you've used it for just a few seconds anyway, if you use the right amperage, it's going to ball up by itself. You don't have to go through all that, especially if you're doing fine corners and stuff. You don't need a big ball on the end of it. Other people will try to teach you to run your tungsten flat with the cup. Keep it flush in there. Negative, Ghost Rider. Have that sucker sticking out where you can see what you're doing. You'll have much more control. You'll be able to can tell what you're aiming at. Okay, as you can see, I'm just tacking these in the fixture. And I'll be welding them outside of the fixture. But I'm using a 3/32 filler wire. And I'm running it at 180 amps. Once you build heat up on one side, the other side will run a little bit hotter, of course, since the part's heated up. So you'll have to adjust just a little bit. I'm going to get them all tacked up first, and I'll come back and weld them out. Having something to hold your torch handy right there. Same thing for having something to put your wire in. Like that, just kind of ease off on that foot pedal when you finish tacking. Oh yeah, and remember this, this is not like steel. Aluminum does not draw like steel does. So do not worry about welding this side and it pulling so much this side, because when you weld this side, you flip it around and you weld the other side, it's going to be just like you started right here. I've done enough of this to know. Okay, going up to 200 amps, and when you know you're ready is when it starts looking like water, and you can just flow it in there. And as you can see, it's still straight up and down. Didn't fold to this side or that side. Remember, even though this is a small part, this is still 1/4 inch thick aluminum. So you've got to get some heat into it before it starts to flow. No matter what you set your amperage. Say I've got my amperage set up to 219 now, and I've changed my tungsten out to a 1/8 tungsten. So that's setting a precedence. I have to get heat into it, because if you just start blasting amps to it, it's just going to start looking like it won't flow right. It will not look right. It will not look even. It will look all janky, and the edges won't be filled in properly. You're just not going to get that look. So what am I doing to get heat into this part? Well, I've even changed my cut size out, because tacking these and then running these welds are a little bit different. Right. What I'm doing to get heat into this is I'm reheating the tacks and wrapping around the corners of both sides before I start making my run. Now when I make my run, I could simply lay it like this if I wanted to, and that way the table is not drawing the heat out. But here's the thing, once I've got enough heat into it, it doesn't really matter. You can lay it on the table, it ain't gonna draw it out fast enough. Not with this high frequency. So watch what I'm gonna be doing. Getting some heat in this whole part instead of just around where the weld is. Now, plus, the more of these you do, the hotter the table will get also.